Okay, we're going to finish week 10 today, which means we have an in-class assignment today. It's the end of week 10. We have an in-class. It's kind of mostly like a review today. I'm just going to throw in a couple of new things, but it's mostly review. What do we got? By the way, after today, we have 1, 2, 3, 4, 5, 6, 7, 8 lectures. That's it. So there's only eight times we're getting together after today. That's it. And then we go to the final exam. This is going to fly by because we're only, today's the 21st and the finals are going to be starting the 20th. So we're 4 weeks away from final exam. 4 weeks and 2 or 3 days from finals. So it's going to go a lot faster than you think. So be prepared. Stay ahead of things right now because they start piling up as you get towards the end. You don't want to fall behind. So stay ahead of it right now. Here's your instructions for week 10. And you have a document, and it's due in 2 days, just like usual. Written, handed in on that table right over there. The usual situation. Let me see what else. Here's the link already. We had a lecture on last Thursday. I'll put the link up tonight for today's lecture. Let's look at the assignment. Here's the assignment. Nobody has handed in yet, and I don't know why. This is one of those rare occasions where usually you get the really important stuff on Tuesday's lecture and then you're ready to hand in your homework on Thursday. But you got everything you needed from last Thursday's lecture for this homework assignment. I don't think anyone realized it. Nothing today has anything to do with this homework. This is all from Thursday. So the first problem, as a matter of fact, the instructions say solve each of the following problems using the appropriate manual equation. That's the first part, either Poisson or binomial. You have to recognize what kind of problem it is, then either solve it manually using Poisson or binomial. Next, write the exact Excel equation with the result. So you're going manual, then Excel. Then third, give the row, column, and result from the corresponding table. Either you're going to use the Poisson table or you're going to use the binomial table. But don't forget, one of them you have 3 numbers to give. There's the column, there's n, and then there's the row. In the other table, you just have your column and your row to give. And then you give the result. If it's, don't forget, if this question is like some question and more or less, then you're giving more than just 1 row. You're giving maybe 2 or 3 rows that you're supposed to be adding together when you're using the table. And you show your work that you're adding those numbers together. Anyway, just remind you. Here's number 1, you gotta figure out whether this is Poisson binomial, do it 3 different ways. Number 2, same thing, let's look at number 3. Same thing, you gotta decide if it's Poisson or binomial, and do it 3 different ways, manual, Excel, and using the table. And then number 4, don't take a whole bunch of time and start entering those numbers onto a spreadsheet. There's no reason. I'm not asking you for the result. I'm asking you to look at the spreadsheet. By the way, this is preparing you for the final exam. This is where I'm asking you, as I put a picture of the spreadsheet there, you're looking at it so you can see the column letters and the row numbers, so you can write an if equation to solve whatever is being asked to solve. What is being asked to solve? Use the picture of the spreadsheet below to write an if Excel equation that would let the user know if the mean of the data is greater than 450 or less than 450. All right, and I put right here to remind you about an if statement right here, equals if, parenthesis, true or false, some kind of true or false equations right there. You could use Excel functions of all kinds. You could use less than, greater than, not equal to, equal to. Use let your imagination, whatever needs to be done here. But in this case, it says you got to find the, what is it, median or the mean? The mean of the data. Comma, if Excel finds that first statement to be true, you're telling Excel what to do if it's true. Comma, if Excel finds that first statement to be false, you're telling Excel what to do if it's false. There's the basis of an if statement right there. That's what I showed you on that if Excel from last Thursday were 5 or 6 different ways to use an if equation, but there's so many hundreds of different ways to use it that there's no way I could show you all the examples out there. You got to just read, the hint on what kind of an if statement you're going to write is those words where it says, where it's telling you what it should be doing, which is to explain if the mean of the data is greater than 450 or if it's less than 450. That's the purpose of the if statement. And there can be more than one right answer for this. So, there you go. There's your homework. Can't believe you don't have it done. You're fired. All right, there's your reading class. Get started on that. Just kidding. All right. Now, first I want to teach you about artistry. No? No, we're not going there? No? Got it. But with life, you need to learn about art and what it means to express art in an artistic way. All right, we'll go with this. Uniform, normal, exponential. These are the ones that we learn that have to do with continuous data. Continuous data. So this is kind of like part of your finals review in a way. I'm going to get into some new stuff you haven't seen. For example, let's talk about uniform. Here's the most important part about uniform right there, slide 4, and it's right here on the board. Density function, density function, density function. As soon as you recognize a problem as a uniform problem, and you all seem to be able to recognize that from the quiz, it's 1 over the largest number minus the smallest number in parentheses. You get that subtraction and then put it underneath 1 over that. There's the most important part. But what you haven't learned, and now I want to mention this statement right here. For example, here's a perfect example of uniform, but we're going to learn something else to use with these numbers. It says Slater's customers are charged for an amount of salad they take. Sampling suggests that the amount of salad taken is uniformly distributed between 5 and 15 ounces. Density function, right? Everybody know what we're doing on density function? 1 over what? Let me hear somebody.
10.
Thank you.
You're welcome.
Thank you. 10. Thank you, Yusuf. Now, what we haven't learned though is how to find what's called the mean, also called the expected value, and the variance, which also is going to be the standard deviation once you square root it. There's the formula. This is only with a uniform distribution. You add the largest and smallest number together and divide by 2. There is the mean, also called the expected value. They mean the same thing. With a uniform distribution, you just take the largest value, add it to the smallest value, and then divide by 2. That's pretty easy. The other one, here's the weird part. You always divide by 12. Somebody wanted to do a research project to find out why you divide by 12, but with uniform distributions, you always divide by 12. I don't remember the exact purpose. Feel free to look that up. But you take the largest number minus the smallest number to find that gap, that spread between the two, just like you do in the density function. Then you square it. Then you divide by 12. You found the variance. Then you square root it. You found the standard deviation. Let's try it with this data. Yeah, where's my pen? I'm going to say it again just because I saw everybody looking down writing. The variance is the largest number minus the smallest number to find that spread, then square it, then divide by 12. That gets you to the variance, but one more step that you don't see up there is square root it. That's how you get to the standard deviation, and that's not on there. So make sure you note that one more step is to square root. Let's do it with this salad right now. You ready? The density function we know is 15 minus 5, because the largest number is 15 minus 5. But to find the expected value, I'll go over here. I'm going to take 15 plus 5. I could have said 5 plus 15, either order. And then what do I do next? I forgot. Square it? Or divide by 2? Oh. Divide by 2? Divide by 2. But we're going to square it in a minute. On the next one, we have to subtract it. 15 plus 5 is 20. 20 divided by 2. Our mean is 10. Our mean is 10, or sometimes called the expected value. What you're really finding is the middle between the spread. You're finding the middle between it. That's what's going on. Okay, now let's do the variance. Don't forget we're using 5 and 15, but I wanted to put the formula up there. So now we're going to take 15 minus 5. We're going to square it, then take that, divide by 12 to get to the variance. I'm going to add the symbol, Square root over the whole thing, because that's what gets us to the standard deviation. Do it in this order. 15 minus 5 is 10. 10 squared is 100 divided by 12. We're almost there. We square root that, we'll be there. 100 divided by 12 is 8 point what? I didn't hear you. 3. So the square root of 8.333333, square root it. Here we go. Whoops, 100 divided by 12 equals 8.333. Now we square root it. Where's square root? Right there. And the standard deviation equals 2.8. We got 8, 6. What's the next digit? We're going 4 digits to the right of the decimal all semester. What's the next digit? There you go. Because it's 7 up there, but the one after that's a 5, so we got to go up to 8. Very good. All right, we're going to look at another one. Going to page 204 from our book. Can't help myself. Well, it's just stuck in my head. I can't get rid of it. It's like a disease. Oh, it's just going on and on and on. It's playing in my head. I'm trying to talk through it. Oh. The manager of a local drugstore is projecting next month's sales for a particular cosmetic line. She knows from historical data that the sales follow a continuous uniform distribution. There's the giveaway, what kind of problem we have. I may not be that obvious on a final exam. It may say, she knows from a historical data that sales follow a evenly distributed process or something like that. That means uniform, but not being so blunt and saying uniform. With a lower limit of 2,500 and upper limit of 5,000. What do I have in my notes here? Only do A and B. Okay, A, B, and C. Doing all three. What is the mean and the standard deviation? Well, same thing with the mean. We add the 2,500 plus the 5,000, which makes 7,500, divided by 2, which makes 3,750, I think, if someone can double check that. That would be our expected value, which is called the mean. Someone confirm 5,000 plus 2,500 is 7,500, then divided by 2, did you get 3,750? Yes, thank you. God, with the dark there, I you had a hand up, that's all I couldn't tell what you're doing. Standard deviation, what would we have to do? How about if I just set it up, instead of doing the whole calculation? 5,000 minus 2,500, parenthesis, squared, divided by 12, square root the whole thing. There's the standard deviation set up right there. 5,000 minus 2,500 would be 2,500. 2,500 squared would be whatever that equals. Divide then by 12, then square root it. Says B, what's the probability that sales exceed $4,000? Okay, here's where the density function comes in play. If any of these probabilities for uniform distribution are always the density function times the spread of the question. The density function times the spread of the question. The density function is going to be 1 over, help me out here, what were the two numbers here? 5,000, 2,550? So 1 over, I'm putting 5K minus 2.5K. K means 1,000, which means 1 over 2.5K, 2,500. There's our density function, times. Here it is. The spread of the question. B, what's the probability sales will exceed 4,000? So what's the spread of the question then? 1,000. Why? Because the upper limit's 5,000. If it's more than 4,000, the highest it can go is 5,000. So this is going to be 5,000 minus 4,000, which equals 1,000. So 1,000 over 2,500. There's our answer right there. Again, let's check and make sure. What was that, B? So A, 3,750 is our mean. There we go. be, wait, there's our standard, had we calculated our standard deviation, but there's the setup. 5,000 minus 2,500 squared divided by 12 square root the whole thing, we would have got 721.69. But what we're being asked about now is the probability of 4,000 or more. So it says the area from 4,000 to 5,000 is 1,000. 1,000 times the density function right there. The density function right there is 1 over 5,000 minus 2,500. So if we did that, that would be 1,000 divided by 2,500, which equals 0.40, 40% chance. So this right here, where's that calculation? Right there equals 0.4, 40% chance. C, what's the probability that sales would be between 3,200 and 3,800? Remember, uniform distribution is always the density function. This is one of the first times I think I can turn this fan off. It is like they got the air conditioning in. Buddy's so tight, we had to turn the heat off. What's so funny? You know what the temperature is in my house right now? 53 degrees. What? Well, who said why? Who said why? How much money am I saving by having my house at 53 degrees while I'm staying here? $10 is $10. Right? That's what I'm saying. If you spend your whole life not wasting money,
you won't have any fun.
I don't know. I had a little bit of fun. Not as much fun as you have, probably. But I had a little fun. Anybody want to hear that song? I'm just raising the monotony. Thank you. All right, here we go. Anytime you have a uniform distribution asking about two numbers that are both within the lower and upper limit of the uniform range, you're just trying to find the range of those two numbers. And that's what you multiply times the density function. So, here we go with the density function again. I had this bell curve here because I was going to use it, but I don't know if I'm going to. 1 over 2,500 is the density function times the range of the question. What's the probability that sales will be between 3,200 and 3,800? Subtract those two, what do you get? Right here, it's 600. Is that what you said? Is that what it is? 600 times, so that'd be 600 over 2,500, which is going to be a very small percent. It's a little more than 10% because 250 would be 10%. So 20% would be, whoops, where am I? 20% would be 500, so it's just slightly above 20%. Let's do the math. 24. Well, the calculator's not there. Not on the screen. What is it? 600 divided by 2,500? What'd you guys get?
24%.
24? 24%. All right. 0.24. All right. So now we can all do uniform distributions. We got uniform distributions behind us. We're never going to talk about them again until the final exam.
Well, before you did that, I just did the 600 divided by the 25, and I got 24. Is that
0.24?
0.24.
Yeah, 24%. That's the answer. Yep. Okay. Yep. This is because the question was about a spread from 3,200 to 3,800, so that was 600, and then the density functions 1 over 600. That's how we got them. Next, let me go here. Let me make that there. Go here. Next is the song I want to play. Just kidding. There we go. There we go. Did we get the same answer here? Whereas did we get 10 and 8.333 for the variance? 8.333 for the variance, yeah. And then we square root that to get to the standard deviation for that uniform distribution. Let's get to the next subject. Normal distribution. Normal probability. Here's our normal to refresh your memory. X minus the mean is the numerator divided by, now, I want to refresh your memory. I talked about this since the beginning of the semester that this formula for normal distribution is going to be changing. This is the transition right now that we're changing. Starting Thursday, we're going to be talking about sample sizes, not just what's the probability of one, it's the probability of a whole sample being something this or that or this or that. So you got to make sure you understand the formula completely. X minus the mean. Matter of fact, let me put this on here. I want you to see the difference. right there. Remember this? X minus the mean divided by the standard deviation. Well, instead, it's x minus the mean divided by the standard deviation over the square root of the sample size. That's the formula, complete. Before this, the sample size was always 1, so standard deviation divided by 1 is just the standard deviation, so that's where you end up. But we are now going to be having sample sizes starting Thursday. So we gotta be prepared for this formula. Using Excel, equals normal distribution. The first number is your x that you're being asked to find the probability of. The second number is your mean. The third number was your standard deviation. But starting Thursday, it's going to be your standard error. That whole calculation with that sample size is called standard error. Standard error. So no longer are you using the standard deviation all by itself because this is a 1. This whole thing is going to be what's placed here now for the third number. And we know the last number is a 1 because we're using continuous data. Normal distribution always has a 1 at the end. Exponential always has a 1 at the end. It's Poisson and binomial that have either a 0 or a 1 on the end because it uses discrete data. All right, so now I want to just a slight review. We're going to do a normal distribution problem, but I'm not doing the one from the PowerPoint. I just want to refresh your memory though. Remember this one? PEP zone. They have a lead time on this oil. They order when inventory gets down to 20, but they usually sell, 15 gallons, and with a standard deviation of 6. So remember all this? This was even on your quiz. This was very similar to a problem on your quiz. Would you recommend the reorder point to be increased or decreased? Does that sound familiar? Okay, just to refresh your memory. But instead, we're going to do this problem. Yeah, right here, and we're going to page 213 at the bottom. That's all you write today. Whoop, right up here. Didn't fit. I'm going to give away the answer again. All right. Scores on a management aptitude exam are normally distributed with a mean of 72, a standard deviation of 8. There we go. Mean of 72 with a standard deviation of 8. The question is going to be about just one sample size. We're still with just one sample size until Thursday. So this is going to be, the denominator is just going to be standard deviation. This third number is just going to be the standard deviation because we don't have a sample size yet. So you're going to say, what's the probability that a randomly selected manager will score above 60? Now with continuous data, above 60 is the same as 60 and above. They mean the exact same. If this were binomial or Poisson, above 60 means 61 or above, but this isn't. This is continuous data. Normal and exponential, you're still using the number 60, even though it says above 60 or more than 60, whatever those words are. So we know X is 60. I can put that in right now. There's 60. Yeah, get rid of the uniform stuff. Make room. Okay. So there's 60. We got that one. Manually, 60 minus. Now, the mean has been given to us. It says, scores on the management aptitude test normally distributed with a mean of 72. So 60 minus 72. There's our numerator. Divided by the standard deviation, also given to us. Standard deviation is 8. 8 over the square root of 1, because the question says, what's the probability that a randomly selected manager, that A right there is the same as saying 1. And that's why this is only an 8 here. But Thursday, that won't be 1 anymore. We're heading to where we have larger sample sizes. So there's the manual way to find Z, and then we would look it up on the Z chart, or we could use norm S distribution. But here, 60, comma, 72, comma, standard deviation or standard error, because that's a 1, we just put an 8 there, comma, 1. There it is. There it is. Okay. Now, here's one we have not done yet. We have not seen this be. This is going to be new to us, and we're going to get more into this I think it's in this next lecture, either Thursday or Tuesday, but it's between two numbers for a normal distribution. Between two numbers is not like uniform distribution. In uniform, we could take, look at B. What's the probability that a randomly selected manager will score between 68 and 84? With uniform distribution, we can subtract 84 minus 68 and then take that spread minus times the density function, but not with normal. With normal distribution, you gotta find the full probability for 68. You then gotta do it all over again, find the full probability for 84. Go to the z-chart for both of them, find both probabilities on the z-chart, then subtract them. That's how you find the probability between two numbers for a normal distribution. With Excel, it's almost the same thing. Okay, don't forget, we're doing B now. So I'm gonna change these numbers to satisfy B. Watch, the only number I gotta change is that first number. I'm gonna change it to a 68. There it is. Now watch this. I'm gonna do another normal distribution. And nothing really changes except for that first number. This is 72, that's 8, that's 1. That first number is 84. Now, if you think about a bell curve, let's say 72 is right here, 84 is gonna be over here to the right somewhere, 68 is gonna be somewhere to the left, and since these are both doing less than, the bigger probability is gonna be from here over compared to here over. So I'm gonna take this statement minus that one. If normal distribution 84, 72, 8, 1 minus, now you don't have to get an equal sign on this one. This one you do. Minus normal distributions, parentheses, 68, 72, 8, 1. That's how you find the probability between two numbers using Excel. Manually, I'd have to do the whole thing for the number 68 and the whole thing for the number 84, look them up on the z-chart, take the bigger number minus the smaller number to find the difference. And that's how you find the probability. I want you to see this on this z-chart, or on this bell curve. Excuse me. Okay, on this bell curve, 72 is right here in the middle. 84 is over here to the right. Well, watch. Hang on a minute. I'm going to do squiggly squills. There we go. Just all the way over. All the way there. So that's one big probability from the 84. But the 68 is way over here to the left. So now I'm doing straight lines with the 68. All this area that overlaps gets subtracted from each other, and what's left is the area between them. That whole thing minus this little part leaves you the probability between the two numbers on a normal distribution. That's why you gotta subtract them. You gotta go all the way to the answer for both of them, then subtract them. All right, let's do another one. Help me figure out what to do here. If I said, what's the probability that a random selected manager's score will be between, forget it. It's too easy. I don't know what. If I said 50 and 100, what was changed? The only thing that changes, matter of fact, watch, I can do this. Now watch what I'm gonna do. What did I just say, 50 and 100, even though I didn't even hardly say it? What's the probability that a randomly selected manager will have a score between 50 and 100? Watch what I'm gonna do. I'm putting the equal sign up here, making this the bigger number, there's 100. The mean is 72, standard deviation is 8 because sample size is 1, and a 1 on the end. Minus normal distribution, and this one is the 50. That's it. That's all you gotta do. You have 1, and you can write it all as one equation. Now, there's students who forget to write this all as one equation with a minus between these two normal distributions, equal in this one and a minus between them. And they'll find the probability for this one, and then find the probability for that one, and then take the two results and subtract them. I'll accept that. You're still getting to the right answer. You're using two Excel equations. It's just that you didn't write it all in one equation. That's all right. You're just giving yourself a little extra work is all. Right, as long as it's working, I'll take it. How do we feel? Let me think. Do I have another normal distribution example in front of me? I don't. Can we find the probability of any normal distribution if we have it on a final exam? Even if it said, hey, well, no. Hey, what about this? I forgot. What about, you know what I didn't do with 60? I didn't realize it says or more. That was 60 or more. Let's do A again. What's the probability a randomly selected manager will score above 60? All right, look it, I did this. This isn't correct. That's the answer for 60 or less. I forgot to put that right there. Now that's the answer for 60 or more. More than 60, 60 or more, whatever, however you want to put it, because it's continuous data. With one minus in front is what I forgot to put. Okay. I don't think I have another example of normal. Go ahead, Alex.
So for B, 1 minus would be there as well?
No, B would not have a 1 minus. B would take, you have them both going less than. Don't be wrong, you could have them both going more than, as long as they're going the same direction, but you have the 1 minus in front of each one then. You could do 1 minus in front of each one, but if you're finding the probability between two numbers with normal distribution, you just want them both less than and find the subtract the 2. As long as they're both going the same direction, the difference will be between them. Hey, let's talk about this real quick. I found a picture on my phone from January 17th when we got together. Crude oil was $80.85, and today it's $69. That's how much oil has come down. The prices back then were $3.11, $3.15, $3.17. So wouldn't you think the prices of today would be lower, especially since this has been down since January? This has been down for at least a week or more. And look at the prices, $3.24, $3.27, $3.34. There's a conspiracy going on. Now, last Thursday, I asked you guys to check into it, but nobody checked into it. I didn't hear from anyone. Am I the only one recognizing this? I'm alone here. There's a room full of people out, and nobody's even answering a single question. I'm talking to myself right now.
I looked into it.
To future Michael.
Okay, that's all I got. You ready? Going to the next one. Exponential. Uh-oh. I'm gonna touch so much now. Go to the next one. Exponential. Getting out early. But you want to give that song? It's 9 minutes. It's a short song. Cody, what's up with that?
It's a long time.
9 minutes? It's art. You can't look at art for 9 minutes? Are you crazy?
No,
Oh my
I've already
gosh.
watched it for 18 minutes.
What?
I've seen for 18, you said it goes.
Oh, right, yeah, that's right, that's true.
My brain's full.
But until it's constantly going in your head, you haven't seen it enough.
So you're saying on the way home we'll be singing the song?
Not yet. Only if I can play it a couple more times.
Ah, that's okay.
Okay. All right. Nicole, will you stick around if I do it after class? No? All right, exponential. Now this is pretty fresh, so I'm not gonna go too deep. Here it is, 1 minus e to the exponent, negative x times lambda. So that's your whole exponent there, negative, whatever you're being asked the probability of, time or length, it's an interval, times lambda. We all know what lambda is because we studied it all spring break. The whole spring break, we did nothing but talk about lambda to ourselves. All week long. So I know we know lambda. Equals exponential distribution. X is your first number, lambda is your second, a 1 on the end, just like normal, always a 1 because we're using continuous data with exponential. What was the other thing I was going to say was, what's weird about this is 1 minus, this is what usually confuses people. This is, and any of these other ones, I mean, Poisson, what am I thinking of? Poisson, binomial, normal. We always have a 1 minus in front manually if it's a more than. This is the only equation that it's a less than that you have a 1 minus in front. This is if it's a less than. If it's a more than, you have another 1 minus in front. So you'd have 1 minus 1 minus. That's what's weird about exponential. So I want to make sure and bring that to your attention again. I know it's been it several times. But when it comes to the Excel, it's back to normal, just like all the other ones. The 1 minus is only if it's a more than. Exponential and normal are the ones where you don't have to change that first number in the parentheses for a more than. Where Poisson and binomial, you gotta use the opposite of what's being asked for in a more than question for that first number. Let me repeat that, because this is the number one mistake also on the final exam. The first number has to be the opposite of what's being asked for if the question's binomial or Poisson. But the first number is not the opposite of what's being asked for if it's exponential or normal. It's whatever's being asked for. Okay, the exponential example. I'm sorry, say
You
it.
repeat that?
Okay, ready? All right. I forgot what I said even. We gotta think about it. What was I talking about? This?
The first number
Is it,
being the
X is the opposite
opposite.
of what's being
There we go,
asked
thank
for.
you. Ready? With exponential and normal, that first number on a more than question is whatever you're being asked. So if the question said, hey, what's the probability of 60 or more? You're still using 60 there with normal and exponential because it's continuous data. You don't change it. But with Poisson and binomial, if the question said, what's the probability of 60 or more? You gotta use the opposite, which would be 59 or less for that first number. With binomial and Poisson, you gotta use the opposite of what's being asked for on a more than question. That's the difference. Okay, so now, we're going to page 222, since you all have your book. Here's our example. Are you out there? Come on. Nope, we have to zoom out a little. I want to give way to the, okay. Let the time between email messages during work hours be, see, I'm not gonna tell you it's exponentially distributed, but it's gonna say a mean of 25 minutes. So I'll put this up here. Here's a mean of 25 minutes between emails. Now let's make sure we understand what that means. We just got an email. Usually now, there'll be 25 minutes until the next email comes to us. We're a customer service, it doesn't say, but let's assume we're a customer service department who responds to emails. All right, and there's usually 25 minutes between them. There's our mean. Think about lambda. Think about lambda in hours. Matter of fact, let's talk about that. Let's do a couple of lambdas here. Lambda for hours and for minutes. Now, if the question says, hey, what's the probability there'll be 2 hours between the next two emails? Lambda has to be how many emails you usually get in 1 hour. If the question says, what's the probability of 10 minutes between the next two emails? Lambda has to be however many emails you usually get in 1 minute. It's 1 unit of whatever the question's about. So let's pretend the question's in hours. The mean is being described. Now let me repeat this. The question hypothetically says, what's the probability there's 2 hours between the next two emails, or 2 hours or more, or 2 hours or less? Doesn't matter. 2 hours. So you're going, oh, X is a 2. Lambda's gotta be however many emails we would usually get in 1 unit, which is hours, so 1 hour. So think about it, if we get an email every 25 minutes, how many would we get in 60 minutes? Let me get my calculator out, hang on, before you tell me, I wanna know what the answer is. We usually get one every 25 minutes, but we wanna know how many we would get in 60 minutes, and you're telling me how many? Not all at once, gosh, you guys were so loud all at once, I couldn't get it. It was like, I heard all these different things, thank you.
2.4.
I hear 2.4, how did you get it?
60 divided by 25.
There's 60 minutes in an hour. We need to know how many emails in 1 hour. If we get one every 25 minutes, we'll get the first one 25 minutes. We'll get the next one 25 minutes later, which takes us at 50 minutes. There's 10 minutes left. 2.4 per 1 hour. There's lambda, 2.4, if the question's in hours. Minutes now. Minutes. Question says, what's the probability there'll be 10 minutes between the next two emails? Lambda has to be how many emails we get in 1 minute, but we don't even get an email in 1 minute. We get an email in 25 minutes. So how many emails do we get in 1 minute? If we only get one in 25 minutes, What part of an email do we get in 1 minute?
1/25.
1/25. We get 1/25 of an email per 1 minute. In the second minute, we get second 25th. In the third minute, we get the third 25th. In the fourth minute, we get the fourth 25th. And when we get to the 25th minute, we finally got one email. So we're getting 1/25 of an email per minute because we only get one in 25 minutes. So now you can see how lambda can be two completely different numbers based on whatever the question interval is going to be about. The question's about hours, or is it about minutes? Matter of fact, we could take this to the real extreme and say, what if the question's about seconds? Now, I don't want to do that calculation. How many emails we would get in 1 second? Because we're already getting 1/25 in a minute. I guess it would be 60, 1/25 divided by 60 to figure out how many we get in 1 second, I guess, right? Would that make sense? Is that right? 1/25 in 1 minute, so we're getting 1/60th of the 1/25 in 1 second. Anyway, what is the question about? A, we're not doing A. B, A is, by the way, what's lambda? But we don't know if the question's in minutes or hours, so we don't know what lambda is. But B, what's the probability that you do not get an email for more than an hour? An hour or more between getting emails. That's going to be, we usually get it in 25 minutes, we're getting no emails, an hour or more. What will be X? Let me do this right now. What would be X in the parentheses for this question? What's the probability you do not get an email for more than an hour?
25.
What is it? What's the number? What's X? Say it. I'm sorry, I couldn't hear it.
I'm wrong.
Well, who told you wrong? 20, see?
Oh, wait, I was right.
No, that's the wrong answer.
Oh, come on.
But I praise you for, hey, he didn't have the guts under his breath,
Well,
won't admit to it until he thought it was right. No, I want to hear wrong answer. It is wrong, sorry. That's right. X is whatever the question's about, Ahmed. What is it?
60.
No, we're not switching it to minutes. It said right there. What's the probability of it being 1 hour or more between emails? I'll reword it. How's that? What's X? 1. Let's say there's 1 hour between emails. 1. And what's the units being asked for in the question? Hours. So what's lambda then? We just calculated. 2.4 emails in 1 hour is what we usually get. What's the probability there'll be an hour between emails? And usually we get 2.4 emails per 1 hour. Comma 1. Okay, there's that one. Now it's time to switch it. Stick with B again. What's the probability we don't get an email for more than an hour? An hour or more between emails. Switch it to minutes. Switch it to minutes. Now tell me what the first number is.
1.
60 minutes between emails. 1 hour. Switch it to minutes to 60 minutes. If we use a 60 because that's in minutes now, what would be lambda?
1 over 25.
1 over 25. Thank you. Nice and loud on it. I appreciate that. Hang on. I left the golden stars back in my office on the way out. Can we go pick one up for you? All right. 125, comma 1. No, I do appreciate it. I wish I could give him a Snickers. I wish I had snack size Snickers, my favorite. I'd throw one at him right now. Hopefully you catch it. There. You see the difference though? The difference is you want lambda to be how many in 1 unit or whatever unit you're using in the question. I usually would leave it the way it's stated. Since it's 1 hour, I would have used 1 an hour, and I would have made lambda 2.4. But either one of those will get the exact same answer. One's in minutes, one's in hours. That's what I wanted you to see. Let's see what B is. Or C, I mean. What's the probability we'll get an email in 10 minutes? Now, here we go. We just went from hours to minutes. Hours to minutes. This one's about 10 minutes. So help me out here. What's X? What's my first number here? 10 it is. Thank you. Is that correct? Oh, thank you. Appreciate it. 10. What's lambda? 1/25 because 10 is in minutes. However many we would get in 1 minute, which is 1/25, and the last number is a 1. There it is. Now this says within 10 minutes. It should be 10 minutes or less within 10 minutes. 10 minutes within means 10 minutes or less. That's why. You'll never get an exponential question that isn't a something or less or a something or more. So you just got to see the wording to figure it out. Because it's always continuous data. Same with normal. It'll always be something or less or something or more. Just depends how the wording is. Go ahead.
So they don't put zero?
No, this isn't asking for exactly 10 minutes, and it never would. Exponential will never ask you for an exact, because the probability of exactly 10 minutes is almost zero.
So do we put one minus?
No, you don't put one minus, because it doesn't say 10 minutes or more, it says within 10 minutes, 10 minutes or less. The word within means less.
For B as well.
B says more than an hour, so I'm sorry, good question. That's right, that was an hour or more. There should have been a 1 minus right here on this one, and right here on this one. Whether it's in hours or minutes, there should have been a 1 minus in front of both of those. I missed that, thank you, Lord. There should have been a 1 minus because this is more than an hour or more. But on that last one, this is within 10 minutes, that's same as 10 minutes or less. Very good catch. Where are we at? Where are we at? Are we on this conspiracy? Is that where we're at? Are we here? I can tell I don't have enough material today. Are we here? Oh, did we review if statements? We did. That's on your homework.
That's a good song.
If you guys are willing to go through this song,
No.
we could go right then to our in-class assignment.
I think we go to the in class, then the song.
Or 9 minutes of a lecture on anything I want to lecture on and not the song, and then the in-class assignment.
Why can't we do the in class?
The song while doing the in-class?
Who said that?
Man, so does
I
thinking.
can't even focus when I'm listening.
I like his line of thinking. Does that interrupt the in-class at all, or you guys really get up and talk to each other as it is? You're supposed, by the way, please go to a different row, do not stay in the same row. I got too many of you making the same mistake and you're all seeing my next to. Don't, you gotta compare to other people. All right,